Okay, so we're going to do a couple of integrations. So we'll do some definite integrals using u subs. And I'm going to show you two different ways that you can do this. So the first one is probably the most common, but it's not actually the one I typically do. But that's where we're actually going to change the limits of integration. So when we see this integral, so square root 4x plus 6 dx from -1 to 3, so these limits of integration, those are x values, right? So we're looking at the net area of this square root function between x equals -1 and x equals 3. Okay, but we're going to do this with a u sub because, right, we have a composite function. So u equals the integrand, du is 4dx. So we're just doing our regular u subs. So I've got my dx, I need the 4, I need to balance. Okay, so far I haven't changed to u, so everything is still the same. But now we're going to go ahead and change everybody over to u's. So I have the 1/4 out in front. I have a square root of u. I have a du, right? The 40x is my du. But these values here were x's, so I need to convert those into u's. So sometimes you'll see, right, u evaluated at -1. So this is an x, so if x is -1, what is u? Right? And if x is 3, what is u? Okay. So let's go ahead and I'm going to do one more writing of this. So I have u to the 1/2 du, so I'm set up for power rule. And then u of -1, so I've got -4 plus 6, so that's 2. And I plug in the 3, so I get 12 plus 6, that's 18. Now I'm all set up fully in u's, and I do not have to go back to x's at all. I'm just going to go ahead and find the antiderivative. So 1/4 times u to the, right, add 1, divide by the new, go ahead and reduce. So we have 1/6 u to the 3/2, and then we're going to evaluate that at 2 and 18. So this is going to be, right, some sort of expression here. So I have the square root of 18 cubed minus the square root of 8, 2 cubed, right? And there are absolutely easier ways to write that are prettier ways, but this is totally acceptable, to me at least. Okay, now the other way that you can do these is by not changing your limits. And so this is, I think some people kind of have an issue with this because I wave my hands for a second and then I get back to where we were. But it seems to work for me. So I'm integrating between 0 and pi thirds. Those are my x values. And my integrand is x times sine x squared. So u is equal to x squared. All right, so du will be 2x dx. So we've got the x, right, luckily, or fortuitous because I made up the problem. So a 2 inside so that I get my 2x dx, a 1/2 out in front so that it balances. So now I'm going to go ahead and write this in terms of u's, but I'm not going to put my limits in at all. I'm just going to leave them blank. So now I have the sine of u du. I'm going to find the antiderivative. So 1/2, so if we integrate sine, we get negative cosine u. Now I'm going to go back to x's, negative 1/2 cosine x squared. So now this is an x, so when I put my limits on there, I am going between x equals 0 and x equals pi thirds. Okay, so let's see what that is. Negative 1/2. That's multiplying everybody, so I'm going to do parentheses, the cosine of pi squared ninths minus the cosine of 0. I don't know what the cosine of pi squared ninths is, but we'll say negative 1/2 times the cosine of pi squared ninths, and then cosine of 0 is 1. And if we wanted to get an approximate answer, I'll go ahead and grab my calculator here. And I made sure I was in radian mode before I turned this on. Looks like you're getting a little reflection of the sky there. So we have the cosine of pi squared divided by 9 minus 1 times negative 0.5. So this is approximately 2.717. Now think about what that is. So you're integrating, this is the net area of the function x times sine x squared between 0 and pi thirds. Approximately that, right? And we're anticipating that would be positive because the x is positive, sine of x squared, so sine is positive on the 0 to pi thirds, so sine of x squared would also be positive. Okay. So I am happy with that answer.